So we've been working on the chain rule, and we've been using a technique called U substitution to help us work through chain rule problems. But I think this number 26 is a good chance for us to start to look past that construct, that tool that we've been using, to the bigger picture for the chain rule. Because I think it'll become more natural for you to think about these problems in terms of an inside function and an outside function. So, for example here, we are trying to find s prime, which is the derivative of sine of 3 pi over 2t plus cosine 3 pi over 2t. And when we're doing the chain rule with the u substitution, we were choosing the function that got plugged in to be our u, and then we were writing out and getting organized and writing down the derivative of sine of u and the derivative of cosine of u, and then multiplying by the du over dx. But we can really start to think about this in just broader strokes and head right to the answer. So the deal is this. S prime, we know, is going to include the derivative for sine of something. In this case, this 3 pi t over 2. The derivative of sine of 3 pi over t over 2, 3 pi t over 2, is going to start out with cosine of that same exact thing, 3 pi t over 2. Right? We're going to end up having cosine u in our problem, and we're going to plug that u back in. Okay, now, what we're going to get multiplied by is the derivative of u, which is just the derivative of this 3 pi t over 2. Oops. And that piece is just 3 pi over 2. Oops, I didn't write that down right at all. Right? And the same thing is going to happen with this cosine. The derivative of the cosine of u is minus sine of the u. And remember, the u was just 3 pi t over 2. And then that's going to get multiplied by the derivative of u, which is 3 pi over 2. Now, just to make sure you agree with me, if I make u equal 3 pi t over 2, that is the same as saying u equals 3 pi over 2 times t, right? That's really what this is. And then the derivative of 3 pi over 2 times t is just 3 pi over 2. So that's why I'm putting u prime in here as 3 pi over 2. And then the way we finish this problem off is we just write the 3 pi over 2 in front of the cosine, 3 pi over 2t, or 3 pi t over 2, minus this 3 pi over 2 sine of 3 pi t over 2. And I think a lot of people tend to freak out when they see this 3 pi t over 2, but it's really just some number times t, and the derivative of some number times t is just that number. And then the chain rule piece is just do the outside function and then make sure you multiply by the derivative of the inside function, which we've been calling u. So hopefully that gives you a little bit different perspective on how to attack number 26. Ultimately, you should end up with this derivative down here when you're all done, s prime. Let me show you one more example that somebody requested, and then we'll get this video done. In problem 33, we actually have a product here, right? This is 4x plus 3 to the fourth times x plus 1 to the negative 3. And the way we generally set up the product rule is we assign one of those factors to be u and the other one to be v, and then we organize ourselves so that we can write out the product rule. So let me start by writing down that u equals 4x plus 3 to the fourth power, and then I'll write down that v is x plus 1 to the negative 3. Now, you'll notice that both u and v are also compositions. So when I compute u prime, I need to do the chain rule. And because we've been using u as our variable in chain rule, that's going to confuse the issue here. So I think in class I told people, to choose a letter like M. I'm actually not even going to choose a letter. I'm just going to see if I can visualize what's going to happen to this thing. So this is going to be a m to the fourth, meaning that the 4 would come down, the m will be here, and it'll be raised to the third power. That's the first part of the chain rule. That's the power rule part. The m is just going to be the 4x plus 3 when we substitute it back in. But I also have to multiply by the derivative of m, right? And that's just going to be 4. The derivative of 4x plus 3 is just 4. So this u prime, without doing all the extra legwork, should be 16 times 4x plus 3 cubed. And I'm going to play a similar trick with v, right? With v, I know this is going to end up being my m, my function that got plugged in, like my g of x. And so I'm just going to imagine what would happen here. I would bring down the negative 3, and it would be m to the negative 4, but I'll just write the x plus 1 in there. And then don't forget that we have to multiply by the derivative of m, which in this case is just 1. And so I would end up writing this as negative 3 times x plus 1 to the negative 4. And now I have my 4 pieces put together so that I can write out the derivative of y with the product rule. So y prime is going to be v u prime, so that's going to be 16 times 4x plus 3 cubed times x plus 1 to the negative 3, then a big plus sign, and then it's going to be u times v prime, so that's going to be, let's see if I can write this, it's going to be negative 3 times x plus 1 to the negative 4 times 4x plus 3 to the 4th. And from this point forward, it's just a lot of algebra and simplifying. I'm guessing that most textbooks would write this as 16 times 4x plus 3 cubed over x plus 1 cubed minus 3 times 4x plus 3 to the 4th over x plus 1 to the 4th. And then depending on how they want to attack this, they might factor it, they might subtract the fractions by getting a common denominator. I don't know if that's anything more than just showing off with algebra. What our goal is to get a formula for the derivative, right, which will help us find the slope of the curve at any particular point. And for me, this version of the answer is just fine. So I'm going to stop there before I do any more algebra and either confuse myself or confuse my students. We did the product rule, and it included use of the chain rule while we were doing the product rule. And that was the point of this exercise. So if you made it to some version of this answer, great work, keep it up. And if you have any questions, let me know. Take care.